Hello guys, I'm going to try to record this information so we can use it. That way we can study on our own and we'll be able to be confident that we're doing this correctly. So I'm going to do it this way because when I'm writing and I'm speaking, it takes me a little bit longer to complete this and I don't want the videos to be for too long. So we're looking at Newton's law of motion. This is page number 22 from our force in motion category 2 section. So right here we're looking at Newton's laws of motion. This is the first law. It's the law of inertia, which states that an object at rest remains at rest, or an object in motion remains in motion, going at the same speed and in a straight line, unless acted upon by an unbalanced force. So this is Newton's first law of motion. And let me go ahead and give you the example. The example that we have right here, it shows a foot kicking the ball, foot of the player. So it says ball wants to stay at rest until an unbalanced force, which is the foot of the player, acted upon it. So then what's going to happen to the ball? The ball's going to start moving. So the second law of motion, okay? The second law of motion is the law of force and acceleration. Let me remove this. The law of force and acceleration, which states that the greater the mass of the object, the greater the amount of force needed to accelerate an object. And right here, we do have a triangle. Now, how did I create this triangle? I did it just like we've been doing it in the classroom, okay? Which means that I get my periodic table, and I use the periodic table. Let me see, where's my periodic table? Here it is. So here's my periodic table, and on the periodic table, I have the net force, mass, and acceleration. So then we've talked about this before. I'm going to draw the triangle. So then this is my formula. Net force equals mass times acceleration. Actually, I have the formula over here. So then what I'm going to do is that I'm going to complete my triangle. I don't have anything up on top or a letter up on top of another like I do for speed, but I do have one right next to the other. So the one that is right next to the other, I'm going to put it right here on the right next to the other section of the triangle. So right here, I'm going to put MA. And my leftover F, I'm going to put it up on top. So then if you look at it, it's F equals MA. Exactly the same right here. Do not forget that from top to bottom we divide. And one right next to the other, I'm going to multiply. So then right here, we look at the formula. We have an example and it says, if I'm looking for the force, I'm going to cover the letter F, which means that I'm going to multiply the mass times the acceleration. If I'm looking for the mass, I cover the M, and I'm going to divide the force by the acceleration. And if I'm looking for the acceleration, I cover the letter A, and I'm going to divide the force over the mass. Now, what example do we have right here? And we have this one. Let me go ahead and remove that. We have the same force. Now, one force is acting on a small mass, so then it's going to have a greater acceleration than the force that is acting on the large mass, which will have less acceleration. So we're using the same forces. The smaller the object, the greater the acceleration. The more massive the object, the less the acceleration. So here we have an example again, force equals mass times acceleration. So now let's go ahead and look at the third law of motion. So might as well remove this. It's the one called action-reaction. And it says for every action, there is an equal and opposite reaction. And on this one, you usually see the forces in pairs. Okay, so right here, and we'll see it over here. So let me go ahead and show you. So right here we have an example. The air is being pushed out of the balloon, and the air is going down, being pushed down, and the balloon is being pushed up. So then here we have the action reaction. I push down and the balloon gets pushed up. Okay. Okay, guys, I forgot to mention that like it says over here, for every action there's an equal and opposite reaction. I forgot to mention that the forces are equal. They're going in opposite direction, but they're equal. So then if the air is being pushed down with 20 newtons, that means that the balloon is going to be pushed up with 20 newtons. So then forces, equal forces, but in opposite direction.